All right, so as we've said, the Bohr model that we've been working with really just didn't quite fit all of the things that we were able to start seeing as scientists. So we had both calculations and experiments that were telling us that the Bohr model was not capturing the full picture of our electron configurations. So what we eventually were able to do is start measuring how much energy, really precisely, how much energy each electron was being held by, and we were able to do a number of calculations using quantum mechanics to decide that really we've got a different way, a new, better way that we would be able to describe the electron configurations. Okay, so electron configurations, again, is just the distribution of electrons in molecular or atomic orbitals. Okay, so electrons, what we kind of realized is that we can't know exactly where those electrons are, right? We kind of know the probability areas, right? The areas where where those electrons are most likely to be, but because of quantum mechanics, we can't know exactly where they are and where they're going. Okay, so they really are in these orbitals, but we don't know exactly where they are. It's just a probability area, okay? So we have two different types of electrons. We have our valence and our kernel electrons. The valence electrons are the highest energy level electrons. Okay, and our kernel electrons are all of the electrons that are in the lower energy levels. Okay. Whoops. Lower energy level electrons. There we go. Okay, so we have four different types of orbitals that we're going to talk about. Okay, there are four different types that we're going to talk about. There are theoretically higher energy orbitals, but we have never been able to observe them. Okay, so within the first principal energy level, right, we have one type of orbital, and this is an s orbital. Okay, so an s orbital is basically just a sphere. Easy, right? There's one type of that orbital, right? We can't rearrange a sphere, it's all the same. So our number of orbitals is just one, right? What we can see is that our principal energy level n, if we square n, 1 times 1 is 1, so we only have one orbital. And that means that we can have 2 electrons in there, okay? Our number of electrons is going to be 2 times n squared, okay? So this is n again. Our second energy level, we have two different types or sublevels. We have the s and the p orbitals, okay? So we have, again, s orbital is just one, and then a p orbital, we have 3 different ways to orient our p orbitals, okay? So the number of orbitals for our second energy level, 1 plus 3 is 4, or we can say, well, we're in the second energy level, 2 squared is 4. Okay, and then if we double that, right, 2n squared, that's going to tell us our number of electrons. We can fit 8 electrons in there. Okay, so I'm going to put our electrons on this so that we remember that over there. Next up, when we hit the third energy level, now we can start including the s, the p, and now the d orbitals as well. Okay, so s, again, only has one orbital type. The p orbitals have 3 types, and then our d orbitals have 5 types, okay? If we count then the number of orbitals, right, 1 plus 3 plus 5 is 9. I can do that math. But we can also do 3 squared, right? 3 squared is 9. Now if I double that, I can fit 18 electrons in the third energy level, okay? And then finally, our fourth energy level, we have s, p, d, and f orbitals. The S has 1 orbital type, P has 3 orbital types, D has 5, and then F, I'm going to guess that you can probably guess, has 7 orbital types. Okay? So our number of orbitals for the 4th energy level, 1 plus 3 plus 5 plus 7, this is going to be 16. Or I could do 4 squared and get to 16 as well. If I then double that, I can fit 32 electrons. So what does it really look like in our atom, right? If we have an atom, right, we're going to have our nucleus here. And then in that, or just outside that nucleus, we're going to have the first energy level, okay? So we've got our nucleus, we've got a sphere for that first energy level, okay? So that's our first energy level, it's just a sphere. The second energy level, we're going to have our s orbital, but then we're also going to have our p orbitals. P orbitals kind of look like a dumbbell. We've got something on top and something on bottom, okay? So we can have it on top or we can have it on bottom, but we have 3 different types of p orbitals, right? We could also have it on the side, or it could be on the front or the back. Then we're going to go into our third energy level. Our third energy level here now, we've got our sphere, that's going to be our s orbital. And then we're going to have our p orbitals. Again, we can have them on top, or we can have it on the bottom. But we could also have it on the side, or they could be on the side, or it could be on the front or the back. Then we also have our d orbitals that kind of look like this clover leaf, and it could be oriented like the clover, or it could be oriented above and below and the side, or it could be oriented front and back. There's 5 different orientations of our d orbitals. Okay, so we start getting this really crazy looking cloud of electrons where depending on which orbital the electrons are in, we know where they are most likely to be found. Okay, another way for us to kind of think about this is from our Bohr model, right? Our first energy level is just that first circle. The second energy level has that second circle, but then there's kind of just this little slightly different energy between the second s and p orbital, okay? So this obviously is way more complicated, but our Bohr diagram kind of gives us a hint as to how we could kind of start thinking about it, okay? So now that we have our different types of orbitals, what we can start thinking about is how our electrons actually fill in those orbitals, okay? So our electron configuration, we have 3 rules that we're going to follow, okay? The Aufbau principle is basically that we're going to fill our lowest energy levels first, and then we're going to fill lowest to highest. So our lowest energy level orbitals fill first. Okay? Then we have the Pauli exclusion principle, and that says that each orbital can only have 2 electrons in it, okay? So 2 electrons, and it has to be an up and a down arrow. That's as much as can fit in there, and they have to have what's called an opposite spin, okay? Finally then, we have Hund's rule, that we're only going to pair when it's necessary. Okay, so we're going to use an apartment analogy to kind of understand this, okay? So we're going to flip over to the next page, and we're going to fill this in together, right? So our rules, we've got a really weird apartment, right? Really weird apartment with a really weird landlord, and he says that we can only fill in using these rules, okay? So obviously we're going to fill from the bottom up. So our 1s, the 1 is our first energy level, the orbital type is an s, can only fit 2 electrons. It's the lowest energy level, the first floor, right? We want to be able to walk in and out of our apartment really easily for some reason. We can fit 2 electrons in there. Those 2 electrons are going to have opposite spins because the landlord doesn't want us having any same-sex marriages in this for some reason. I don't know why. But We have that, and we have an up and a down arrow. Then we're going to go up to the second energy level, right? This is our whole second energy level here, and the second energy level really holds the 2s and then the 2p orbitals, okay? So the 2s, again, we can fill in 2 electrons, okay? It can hold 2 electrons. Then we're going to have to go up to the second part of the second energy level, which is our p orbitals. They're a little bit smaller apartments. That's why we wanted to fill the s apartment first. Now we got to fill in the p apartments. The p apartments can each hold 2 electrons, but they're kind of smaller, okay? So what we're going to do is we're going to fill in 1 electron first. You'll notice that I always do up arrows first, right? And then, now that we have to start filling them in, right, and pairing them up, now we're going to pair them together. Now we're going to pair them together all the way across, right? Because this is the same energy level, so I don't want to go up to a higher energy level. I have to keep filling these in, but I'm going to spread them out first, and then I'm going to pair them, okay? Then I would go up to the third energy level. That third energy level, right, we've got the 3s and the 3p, and then we've got the 3d that's even higher. But we're going to go 2 electrons that can go into the s orbital, and then we'll have to go to our p orbitals, and we'll go 1 electron, 1 electron, 1 electron, right? We're going to spread them out as much as we can first, and then when we have to, we're going to pair them. And we pair them with opposite spins, okay? And then, this is where we said that we can kind of fit 8 electrons in that third energy level, and then we can kind of fit 18. Once we hit the filling up the p orbitals, we actually go and we fill up the 4s orbitals first, okay, before going up to the 3d orbitals, okay? So we'll fill in our 4s orbital with 2 electrons, and then we're going to go up to the 3d orbitals, right? Because these are even smaller, so they're kind of higher in energy than the 4s, okay? So then now here, we'll fill 1 electron into each apartment, right? 1 electron into each apartment, and then now we have to start filling them, so we're going to fill them with opposite spins, okay? Once I fill them with opposite spins, then I would go up to my 4p orbitals, okay? So what we end up doing, and I'm going to flip this over to the other side, we have a special order called of our electron filling, which has kind of a tree-like structure, okay?